The other day we talked about how to find an antiderivative in doing an indefinite integral, and we found that, for example, when we integrated x squared, we got this whole family of functions. So when we integrated x squared the other day, we got not only does x cubed 1/3 x cubed have the derivative x squared, but so does 1/3 x cubed plus 2, 1/3 x cubed minus 2, 1/3 x cubed plus 100, plus 1,000, minus 1,000. So that value there, we replaced with a constant of integration called c. So we said that there was a whole family of functions whose derivative, if I were to take the derivative of any function that was 1/3 x cubed plus any constant value, I would get back to the integrand inside. And so that's also finding a general solution. So a general family of functions will mean that we're doing an indefinite integral, and we have that plus c at the end. So here on page 2 of your notes, your chapter 4 packet, there's a giant problem there where the integrand is this huge expression. And so what we do is we just go term by term. So anything separated by plus or minus. So the antiderivative of secant squared is tangent of x. The antiderivative of x cubed is x to the fourth increment by 1, and then times by the reciprocal, 1/4 x to the fourth. Minus 3 to the x, we know it's going to be minus. The derivative, so go backwards, the derivative of 3 to the x, an exponential function, is itself. So its antiderivative is itself, but when we're taking the derivative, we times by ln of 3. So when we take the antiderivative, we do the opposite and divide by ln of 3. The derivative of cosine is negative sine. So therefore, the function that would get me sine of x when I take its derivative is negative cosine of x. The derivative of negative ln of x would get me 1 over x. So this is negative ln, and remember to include the absolute value of x. And this one might be hard to recognize, so look back at your notes. But the derivative of arc sine would get me 1 over square root of 1 minus x squared. And lastly, cosecant cotangent, the derivative of negative cosecant of x would get me cosecant cotangent. And since it's positive, I want to make sure I include the negative here to undo the fact that it's normally negative, and negative times a negative would be positive. And then at the very tail end, we don't forget to include the plus c. Okay, so this is just a practice problem in finding the general solution. Sometimes you guys are asked on tonight's homework, you're going to be asked to find a particular solution. So on the back of this page, or at the bottom, or on a separate sheet of paper, I'm going to do one example here. Actually, we'll call this example 2. This question is going to ask us, instead of finding a general solution, this is going to say find a particular solution. And I will talk to you guys about what that means in just a moment. So find a particular solution. You're given the second derivative is equal to x to the negative 3/2. That something called your initial condition is the first derivative at 4 is equal to 2. And then another initial condition is f of 0 equals 0. And they want you guys to find out what the original function is. Okay, so what is a particular solution when compared to a general solution? So if you guys will recall that example I gave above about 1/3 x cubed being a general solution, well, if we think of 1/3 x cubed shifted up and down as the family of functions whose derivative would get me x squared, you'll notice that this is an infinite number of functions that when shifted up and down, its derivative remains the same, where the tangent lines at each one of the points give us the same value. And so when we find a general solution, it encompasses the entire family of functions where that plus c is the variation. When we find a particular solution, This means that they want me to find the antiderivative, but the specific or particular solution they're looking for has to go through a particular point. So if they were to say, find the particular solution, and your initial condition is that it has to go through 0, -2, that's going to allow me to solve for what that specific C value is, so that I come down and narrow my solutions to a specific function, so that this is my answer rather than the whole entire family of functions. So let's say we were given the second derivative. So we want to ask ourselves, well, if I take the antiderivative of the second derivative, what function will I get? Well, that will, if I'm undoing a derivative, that would get me the first derivative. So what I first start off with is finding f prime of x. So we're going to first find f prime of x by integrating the second derivative. And again, remember this is antiderivatives, and it's the reverse of taking a derivative. So whereas taking a derivative, taking the derivative of the first derivative would get me the second derivative, now I'm undoing the second derivative and going backwards, which would get me the first derivative. So when I do that, let's go ahead and sub in the function. X to the -3 halves x, or x to the -3 halves dx is my second derivative. Now we use the power rule, we're going to increment by 1. So if I add 1 to that, I get x to the -1/2. And remember, multiply by the reciprocal of -1/2, which is -2. And then again, we have plus c. So at this point, this is the general solution, but I want the particular solution where the initial condition is f prime of 4 is equal to 2. So again, this is the initial condition. And so what we do is we plug everything in. So when the first derivative is evaluated at 4, we get 2. So all that means is if I plug 4 in for x, the first derivative should be equal to 2. So 2 is the y value, -2, and then plug 4 into my x value. So if I take the square root of 4, put it underneath that, that gets me, so this is a negative, which means it goes under. Square root of 4 is 2. So -2 over 2 is -1. Plus c. So we see that the initial condition allows me to solve for my constant of integration, and I get c is equal to 3. So the particular solution to this is that f prime of x is the function x to, or -2 x to the -1/2 plus a 3. So I took this and figured out what c was, and then replaced the c in that expression or equation. Okay, so that doesn't answer the question because now they want me to find f of x. So we do a whole nother iteration of this. So I'll switch colors. So now we go, well, what is f of x? Well, f of x is the antiderivative of f prime of x dx. So f prime of x is, from what we just solved above, -2 x to the -1/2 plus 3 with respect to x. So let's go on this. If I add 1 to -1/2, I'm going to get x to the +1/2. If I times by the reciprocal, -2 is already there. So if I times -2 by the reciprocal of 1/2, I get -4. And then the antiderivative of 3 is plus 3x. And then don't forget, this gives me a general solution where the plus c represents the whole family of functions. And now I go back, and here is my other initial condition, f of 0 is 0. So I go back, I plug 0 in. So this is what f of x is currently. I plug 0 in for y and plug 0 in for x. So I get that c is 0. So my final answer, the particular solution for f of x, happens to be -4x